Well, time to stream. This is going to be me building a stochastic implied volatility surface. Yeah, let's get right to it. So you guys can chat. I'll just be coding. So let's see. I want to have the option price, so I'm going to define option. So the binomial options tree takes the stock price, the strike price, the risk-free rate, the dividend yield, the volatility, and the time. And I'm just going to do this for call options. So this will end up being well, the first thing I'm going to compute is steps, which is going to be equal to 50. Maybe I can make it changeable in here. So steps equals, put 6. I'll start off with 4, just so I can see the pattern. So this will be, um, let's see. Is there anyone in here? No, not yet. Got the live chat in. Okay, so dt equals t divided by steps. I do that first because I always forget about delta time. So then the next step is going to be up equals e to the power of volatility times, shit, why's my nose so fucking itchy? Volatility times the square root of delta time. Um, and then down equals 1.0 divided by up, just the inverse. Um, and then probability is going to equal uh, e to the power of r minus q, so risk-free rate minus dividend yield times delta time minus down. Oh wait, no, minus down divided by up minus down. So we got the probability. So now it's time to come up with the rows and columns. So rows are going to equal 4 times steps plus 2. Um, Wait, there's an audio issue? Oh, it says open studio. Alright, it's good now. Wait, no one's in here yet? Alright, I'll just keep it going then. So columns, I'll call it calls equals steps plus 1. So now I will do tree equals numpy dot zeros of rows and columns. So then this will end up being for I in range columns, or rather no steps. This will be tree. Oh wait, I need the center variable. So I'll do center equals the integer of rows divided by 2 minus 1. And then the way that I know the dimensions of the rows and columns is I've coded this algorithm a bunch of times and had to do sequence math to figure it out. But there is that video of the trinomial tree, which is the first video on my channel. So if you guys want to check that out, I think I get more into depth about finding out the patterns to compute 4 times n plus 2 or whatever it is. So yeah, make sure to check that out if you have any confusion with it. But this is going to end up being tree of center minus 2 times I plus 1 equal, wait, I have to initialize the stock price. So tree of center 0 equals stock price. This will be tree of center minus 2 times I times up, and then this will be tree center plus 2 times I plus 1, I plus 1 equals tree of center plus 2 times I of I times down. And I'm going to print tree. Okay, I keep doing Command S, forgetting that this is not a Mac, it's a Windows. But this will be, oh wait, let me actually call the function. So this will be option of 100, 105, 0.05, or 6, whatever, 0.02, 0.2, 1 divided by 12, and I won't mess with the steps. Again, I do that. What the fuck? Okay. Binomial tree.py. Okay, so we got the tree growing. That's good. So now that I got that set, what I'm gonna do is do tab on this. I'll call this CS equals 0. And I'll do while CS is less than calls. Yeah, while CS is less than calls. So this will be CS. And the reason why I'm doing this is I want this to carry over here, and I want this to carry over here, and so on and so forth. So I'm going to have to do steps minus CS. So this will be CS plus I plus 1, modifying the columns. CS plus I, CS plus I. Um, okay, so then this will be CS plus equals 2. Again with the Mac versus Windows. Oh wow, I didn't even save this. Okay. Okay, so the tree has been generated. Let me let me just come over here. I'm just gonna ask Google a question: how to display all columns and pandas. Okay, so this is what I need to do. So Control C, come back here, import pandas as PD, and then I will do Control V. So what I'm gonna do is actually just turn this into a like an actual array. So I call that trees. So trees equals PD dot data frame of tree. So let me reset that. Okay. And I could possibly do it as um. So if I do, well, I don't want to get off track from the video, but let me go ahead and increase the number of steps. So I'm going to come here and do steps equals 8. Let's see what this prints out as now. Okay, so it's gonna siphon cut off like that. Well, I'll just keep it this way. It'll be um easier to work with. Or I'm sorry for causing this delay. I'm just gonna we don't need pandas in here. Sorry for that. But anyways, so reset. I keep forgetting this is fucking Windows. Okay, Python binomial tree.py. Yeah, this looks easier to understand. Okay, so now I'm going to go to finding the payoff over here. So this is going to be for I in range rows. Um, is there anyone in here? Oh, nice. We got some in here. Um, so I might have the allergies or something. I just feel like shit right now. But you know what? Fuck it. Keep coding. So I will do if I mod 4 equals 0, print tree of I and the last column. So I'm going to open up a new terminal and I'm going to, it's going to be the same one. So it's going to be Python binomial tree dot py like 112, 194, 80. Okay, perfect. So I got it. We delete that. So now this will just be tree of I no, I plus 1 to the column, to the last column equals the max of 3 of I -1 minus strike to 0.0. Then I'll come here and print tree, run it. Okay, so there are some payoffs in here, so that's good. So now that I did that, I need to do the backwards discounting now. So I will come here and do for I in range steps to 0, -1. Um, so I will declare, so I need to start off at 3, 4, 5. So no. 1, 2, 3, 4, 5. 1 and 5. So I will call it A, B equals 1, 5. So now over here, I will do while B is less than row rows minus 2 times I believe. 2 times steps minus I. So then this will be A plus equals 4, B plus equals 4. So I'm going to print, maybe I should do it here. Rather, okay, before I do that while loop, I need to figure out like A and B. So A needs to go from 1 down to 2, 3. So A has to increase by 2, B has to increase by, so that's 1, 2, 3, 4, 5. Okay, so I will do A equals 2, so A plus equals 2 times, rather A plus equals 2, B plus equals 2. So let me come here and print A and B. Let's see if these match up to the dimensions. So I'll do CLS, run it. 3, 7, 5, 9, 7, 11. Okay. So I think, yeah, it is it's doing good. So then I will now do while um oh, that's the thing. I'll call this AA BB equals AB. So while BB is less than rows, it'll be AA plus equals 4, BB plus equals 4. So then it'll be, I'll call this payoff equals tree of AA to I. Oh, I believe this would actually be I minus 1. Yeah, it would be I minus 1. Or no, it would be I. Um, so this is going to be probability times tree of AA I plus 1 minus probability times tree of BB to I. So let me go ahead and print pay, or rather, let me just do it as tree of, oh, so CC equals numpy dot mid, or I'll just do it manually. Integer of 0.5 times AA plus BB. So then this will be tree of CC to I minus 1 equals payoff. So let me go ahead and oh my God. Okay, run it. Alright, why is this doing this now? Well, it ran. Um, oh, right, I forgot. So every time, this is going to be 2 times steps minus I. So this should be 0 at this moment, but then it's going to be, wow, is that it? Um, wow. Okay, well, time to not feel so fucking excited. Time to test this shit to see if it even works. So let me just go to my, so 72 cents. Okay. What I'm gonna do is come here, do my strike price of 105, my underlying asset price of $100, my days till expiration to um 30 days. So it's not going to be equal. Well, I'll do 30 divided by 365. And let me also change this number of steps equal to 100. I will print out price. So no, return tree of center plus 1, column 0. Call this price equals that. And then I will do print option price. So price. So clear. 71.6. Okay, so let's test this shit up. So, oh, has no one said anything in the chat yet? Well, time to keep watching. So this option price calculator, so $100, 105 strike, days till expiration 30 days. Dividend is gonna be 2.00 for 2%. I don't need exercise dividend, but I need my number of steps equal to be 100. This is a call option. Volatility is 20% in this simulation, and the risk-free rate is 6%. So let me hit calculate. So it should be 0.7161. Okay, that's close. I got 0.713. This is 716. So yeah, it was probably just a error in rounding. I mean, I got the same amount, 6%, 20% days to American. Um, okay, I guess I shouldn't worry about it too much. It's so close. Um, 30 days, 365. Oh, maybe 0 0.2, maybe let's see 252. Yeah, let's check out and see what it would be with 252. Oh, it's different completely. So, yeah, 365. Okay. So, um I guess I don't know. Should I? I mean, it's literally, well, no, it should be perfect. Yeah, I'm not gonna worry about it. So let me come back here. So I got my binomial tree, returns the option price. So it's pretty close. So now I will open up options.py. So the first thing I'm gonna do is from binomial import option. So it's gonna be from binomial tree import option. Yeah, because I don't want to spend so much time just looking at that one little error in here. Like, it's all right. It's not the end of the world. Um, so anyways, yeah, from binomial tree import option, import requests, import JSON, um, import numpy as NP, import pandas as PD. Hold on, you know what? No, I'm not content with this. Okay, maybe what this is what I'll do. I'll import all of these variables right now and do. No, I want to do that. Just print option. So 100.0, 105.0, 0.05, 0.01, 0.25, 10 divided by 365, steps equals 100. Yeah, this needs to be correct. Um, so I could just come over here and do Python options.py. Okay, 26 cents. So now I'm gonna come over here. So 105 underlying asset price $100. Days till expiration is gonna be 10 days. Dividend is gonna be 1.00. There's a leave blank for dividend yield. Um, this is a call option, 100 steps. The volatility is going to be 25%. The interest rate is going to be 5%. So I'm going to go ahead and hit calculate. 260. Okay, I can accept this. This is working. Um, okay, no more of that. Now, what I need to do is, so I got requests, so I'm going to define self.con for connection, and it's going to be requests.get, no, session. So then I will define get rates self. So this will be response equals self dot connection dot get self dot rates URL dot format self dot key dot JSON. Um, so then I believe it'll be response equals response 0, and then return for you in for you v in response dot items if u is not equal to date. So I will include float v divided by 100.0. So let me come over here and print out fmp dot get rates. So now run it. Okay, perfect. So I'm now going to do a function called match rates. Match rates, self rates and time. So this will be if time is less than 1 divided by 12, return rates 0 for the 1 month treasury. Elif time is less than 2 divided by 12, return rates 1. Elif time is less than 3 divided by 12, return rates 2. Elif time is less than 6 divided by 12, return rates 3. Else, return rates 4. But I'm going to tell you guys right now, I'm not going to be going all the way up until even 6 months in this simulation. I'm probably going to cap it off at like 3 months, but yeah, let's just keep it going. So that's match rates. Now what I need to do is the geometric Brownian motion. So this will be define GBM. So it takes self, SK, drift, fall, time. I'll call it nodes equals, or I can just do it in here. So paths equals 25, nodes equals 1000. I'll do something like, yeah, 1000's all right. So in order to do this, I need to just come here and do payoff equals empty list. Um, so this will be Oh, wait a minute. Before I actually even do this, I need to import the dividend yield. So yeah, so we got get rates. Um, I'll just do get params here. So def get params, and it takes the argument of self, ticker, and start date equals 2025 0101, but this will be adjustable. So I will do response equals request no self dot con dot get self dot hist URL dot format self or rather ticker self dot key, and this is going to be plus an and symbol, and I'm going to call this from equals. Let me also make it an F string. So from equals start date dot JSON, and then response equals PD dot data frame of response historical um, adjusted close dot values reversed, and then I will do ROR so stock price is going to equal response of -1, the last element. Um, ROR, the rate of returns are response 1 divided by response -1 minus 1.0, and then it'll be mu, or rather drift, equals numpy dot mean of ROR. Volatility will be numpy dot standard deviation of ROR, and stock drift fall. Um, oh yeah, might as well do the dividend yield in here too. So that'll be um, divs equals self dot con dot get self dot dividend URL dot format of ticker. Is that what it is? Yeah, ticker and key. Um, okay, so yeah, that's for dividends. So dot JSON. So I believe dividend will just be return divs of 0 of adjusted, no, just dividend divided by the stock price. Okay, so now I'm going to return stock price, drift, volatility, and dividend yield. So I'll come down over here and let me just do fin equals FMP. So then this will be print, uh, yeah, print fin dot get params of ticker. So I'm going to make this ticker equal to SPY. Save that. Run it. Replacement index to at wait, what? Self.con.get. Get. Wait, isn't that hist URL? Oh, it already is a part of that. Okay, I completely forgot. So this will be uh from so is before API key. So this will be start date. Okay. I was about to say like what the fuck did I do? Um why did I open that? Okay. Okay, well, I guess I'll work with this. They don't like, I don't know. But, well, okay. Time to not be just petrified. Okay, so I will do stock, drift, volatility, and dividend yield equals fin.get params of ticker. Um, so I have the stock, I need the strike, I got the drift, I got the volatility, and I need the time. Okay, so I will come down here and now do k equals numpy dot, I'll call this ks, no, ki equals numpy dot, well, all right, options is going to equal 30. So this is going to be ln space of the stock price minus $100 to stock price plus $100, and it's going to have an options length. So ti for time is going to be numpy.ln space of 5 divided by 365.0 to 50 divided by 365.0 options. So then I will do x, y equals numpy.mesh grid of ki, ti, and then now it's all about computing the prices. So what I'm going to do is do fin.gbm, no, lowercase gbm. I'll try to populate it with as much information I have as right now. So I'll do the stock price. I'll do the strike price at like stock price times 0.9. The drift, rather, I'll do stock price times 1.1. The drift is already here. The volatility is already here. The time is not here. I'm going to set time to 15 divided by 365.0. And is that all I need? Yeah, vol and time. So now that I'm in here, I'm going to come here and do 4 p in range paths. S0 equals 0. No, S0 equals S. And DWT equals numpy.random.ran normal of nodes. So then this will be for n in range nodes. I will do S0 plus equals the drift times S0 times, oh yeah, I forgot the DT. DT equals T divided by nodes. So DT plus volatility times S0 times DWT of n. And then I'll come over here and do payoff dot append the maximum of the stock price minus the simulated stock price minus the strike price 0.0 point 0. So we have no negatives, and then I'll just come here and return numpy.mean of payoff. Okay. Oh yeah, good morning. Oh, it's good night for me over here, but all right. So let's see. Is everyone's okay? Okay, so I got the mean of the payoff. So instead of doing it like, let me comment this out. So this will be for uh, I'll call this P equals numpy dot zeros of options by options. So this will end up being for I in range n options, for j in range options. Um, so I'll call this price. So premium equals fin.gbm So this will be the stock price. This will be the actual strike price, X of IJ. This will be the drift, the volatility. What did I call it up here? VT. And then time, which will be Y of IJ. And then I will do P of IJ equals premium. So now let me come over here and do fig equals PLT dot figure. AX equals fig dot add subplot 111, or rather 121 projection equals 3D. AY equals fig dot add subplot 122 projection equals 3D. AX dot plot. Oh wait, do I not even have matplotlib? Oh wow, I don't even have matplotlib. So import matplotlib dot pyplot as PLT from MPL toolkits dot mplot 3D import axes 3D. Um, okay, save that. So ax.plot surface is going to be x, y, p. Color equals red. plt.show. So clear that up, run it. All right, I should probably add some sort of like visual indicator to it, but here we. All right, what is up with this? They are coming down, but it's really weird. Okay, XYP. Oh, okay. So now, um, I'm going to declare a new variable called IV equals numpy dot zeros of options to options. It's going to be same parameters, but the difference is I have to now, so I'm importing option. So, wait, do I have the, okay, yeah, I have this is going to come in handy now, the match rates function. Um, so I will come here, define, um, Vega first, SKRQVT. So this will be P0 equals option of SKRQ V minus 0.01 T, and then P1 is going to be option SKRQ V plus 0.01 T. So then I'm going to return P1 minus P0 divided by 2.0 times 0.01. So that's the Vega. Now I need the implied volatility. So this is IV. So it's going to take O op SKRQT as an argument. I will choose V0 equals 0.6, V1 equals 1.2. For I in range 5, because these should converge very fast. Um, I'm going to end up doing, I'll make it 6. So this will be V1 equals V0 minus option of SKRQV0 T minus OP divided by Vega of SKRQV0T. Yeah, that's set. So if the absolute value of V1 minus V0 is less than 0.0001, I'm going to break the loop. and then I'm going to iterate it to make v0 equal v1 at the end of the loop. And then I'm going to come here and return numpy, or rather, I could just do it as max minimum of maximum of v1 0.0, and I'll do the minimum of 6.0, rather 10.0, so that way they don't turn out too big. So I have the implied volatility function over here, so I need to come over here now and do rf equals fin.match rates. So I have to input the rates, which will be, oh wait, did I not? Okay, so this will be, hang on, I think I did it somewhere. Fin.get rates. Oh no, I didn't. You know what? I'll just do it over here. So this will be rates equals fin.get rates. Takes no arguments. Let me come back here. So this is going to be rates and time, which is y of ij. So now I will do price or no, I vol I volatility equals um G no IV. So the option price is P of IJ. Rather, I'll just type in premium. It doesn't fucking matter. Premium. The stock price is the same. The strike price is X of IJ. The risk-free rate I got. The dividend yield I computed as well. Yeah, I got Q dividend yield. The time is gonna be Y of IJ. Okay, so now I'm gonna come here and print. Oh wait, let me actually populate the array by. Wait a minute. No, I can't do that. I gotta add the extra letters to that because I was about to conflict with the array that I made. So this is gonna be ivol. Um, so ivolatility. This will be IV of IJ equals ivolatility. So now I'm gonna print the strike, the expiration, the premium, and the I volatility. So now I will come here and do ay.plot surface of x, y, IV, cmap equals HSV. And let me add some labels to it. So ax.plot surface, no, ax dot set title simulated prices, and ay.set title simulated fall surface. The x-axis is the strike price and the y-axis is the expiration. Um, so now let me run it, hopefully for one last time. Uh, so it is printing out the implied volatilities. That's good. Um, okay, so here's the simulated prices, and here's the simulated implied volatility surface. Um, yeah, I mean, this is exactly what it looked like when I simulated it in MATLAB not too long ago. Um, yeah, it was chunky like this. It was weird, but we can see the curvature in it. It's just options that, yeah, it's just That just happens when you use real-time market data. You're not going to get like a perfect result with this. But yeah, I don't quite know what else to do unless we want to try out different stocks. Um, yeah, I think hang on, if I come to financial modeling prep, um, API documentation, there are some limits on dividends that I could import. Let's see, where is it? Calendar, oh yeah, limited access. So I can only import Apple, Tesla, Amazon, micro. You know what? Maybe I will just do this right now. So let's start off with Apple. Let's see what Apple looks like for us. And what I'll do is I'll also just run it. Yeah. So let's run this now that it's working. Oh, I'm seeing more nans in here. Okay, so those are the simulated Apple prices. Now this fall surface looks very different. It's like shaped like a almost a triangle. That's weird. Um, I mean the simulated prices look on par. Oh, wait a minute. I did reverse it. Oh, okay, yeah, yeah. Well, that was Apple. Let's see what else is on this list. Let's look at. We already did Spy. I want to do something else. Uber. Yeah, fuck it. Let's just look at Uber. We'll see their fall surface. Does Uber not work? Let me try JP Morgan. Yeah, let's check out JP Morgan. So I'm seeing a lot of nans in this one too. But that's the thing. The only data that we're importing it, well, we're importing a decent amount of data. Okay, this fall surface looks better too. It has the spike in at the money or in the money and then slows down somewhat. So yeah, that's that. What else can we do? Palantir. Yeah, let's check out Palantir. See, Palantir is a very innovative company. Like, I would love to work there. Let me just go ahead and run this. Oh, so that was not supported. So it seems like this should be updated. Sorry, Microsoft. Run it. Okay, Microsoft worked with it. Okay, so let's zoom in on this. So yeah, Microsoft's looking good and choppy. Um, let's see like the back of it. So yeah, we can just see like as the expiration gets better, the vol goes down. Um, here's their prices. Nothing too nothing too shabby. Um, okay, so we keep looking at these different fall curves and whatnot. I'm gonna add it to 60, and then I'm gonna do buy. So I'm increasing the grid size so it can be more detailed plot. This one is gonna take a little bit. I got this. Yeah. So this will be Python options.py. But it's just like programming these models with, see, that's the thing. Like you gotta program these with market data. French stuff. I'm not working anywhere right now. I'm just finishing up school, but I'm more so like trying to get into the IT industry, just to have a paycheck coming so I could fund my trading accounts and stuff. So yeah, I gotta finish school, you know. Because if I were to do finance, to be honest, it would be too limiting. Because I would be spending a lot of time just looking at like cash flow statements and stuff. I'm an information systems major, so I've been learning. I like since I've been at this university, I've learned a lot about machine learning and like just systems. Like it's cool. So I'm using all that knowledge to like, because that's the thing. I learned SQL in my major. Like I had no clue what SQL was, and my professor even mentioned Rust one time, and that's what got me to like look into it and was like, okay, so yeah, here's the simulated fall surface for SPY. Yeah, we can see they're like coming down. But everything's stochastic though, so it's all good. Um, prices coming the same. So yeah, what should I do? Okay. Um, let me see. What if I start off at 2024 0101? Oh no, I can't write from this. It'd be start date. Is that what I called it here? Yeah, start date. So 2024. Run it. So an extra years of data in this. Let's see what happens. So yeah, this is for SPY. So there seems to be a lot more. Did I do something different? Oh, did I even save it before I changed it to 60? No, I think. Okay, I think I know what's going on right now. Well, again, the same result. My change didn't really do much to it except maybe make balls. Oh, yeah. You know what? I think I'm. Oh yeah, I changed the date. So I think I'm pretty much done with this. Oh, all I could say, French toast, all I could say is either C++ plus plus or Rust. Get good at one of those languages because everybody, well, I would definitely suggest also practicing Python, but pretty much everyone knows Python at this point, don't they? At least to some degree. If you want to really stand out, yeah, C++ plus plus and Rust. And I'm learning Rust right now too. It's very difficult, but once you get it, you can do whatever in it. So yeah, that's what I'd recommend. Um, okay, so enough of this. We get the point. Building stochastic fall surfaces. Let's see. Let me exit that. I'll just minimize this. Might need it later. Okay. Well, yeah, that's what can I do? I want to code something else right now. What should I do? Because I don't most of my like I don't have much code on this on my Windows laptop as much. Maybe I should old. Okay, I think what I'll do is backspace out of that. I'm gonna show you guys some algo. So this is my system from a long time ago. Um, doesn't even work. These keys are like deleted a long time ago. Um, so let's start off. So this is a full stack web application that I built, which trades Bitcoin, and I'm gonna first um import all of these libraries here, and then I extract the US dollar balance with this decorator I have here. So I call that decorator on balance because this endpoint imports all of the balances, but this one just makes sure it's US dollar. So then this is my API class for it. So I get my key and my secret. This is the signature, the communicate function, which places the orders and gets the balance and stuff. Cancel order, market buy, market sell, limit buy, limit sell, open orders, edit order, check fill. So there's a lot in there. And then this is my data class. So this is the function synchronize, which checks to see if like the data is in sync. Um, this is pull Kraken, so I just get the highest bid, lowest ask, and price. This is pull Coinbase, so what I do here is I store the prices, store the order books, and then update the order book. And then this is order book stats. This is how I like compute all the metrics for it, like the summations, the cumulative volume, the weighted book average price. So this is X limit buy. So this was one of my first ever limit order engines. What it does is just bids or asks for the best price by just battling other algorithms to get the right price. So on bids, it would set a certain price and then it would bid up until that price gets filled, and vice versa for the ask one, which would go down. And that's to like mimic a market order, but limit orders cost almost half as much as market orders. So that's that. And X limit cell, same thing, the fluid order engine. So then trader, I have like the URLs and everything. I start the socket, I have the session, and then I run the tasks. So this is the server. So this is where the Kraken feed is loaded. This is where the Coinbase feed is loaded. This is the trading strategy. So go long if a certain time has been met, price greater than the book average and whatnot. They're very basic. It's nothing like too advanced. And then this is the server feed. So this is what's like sent to the server. So yeah, then system initialize. So now I'll come to the front end and do app.js, and then this will just have like the custom WebSocket, the parameters in the constructor that need to be initialized, the socket connection and importing and streaming, plotting the P&L and like the distribution of the P&L and the order books, and then just building the interface to show the price, highest bid, lowest ask book ratio, volatility, and plotting the profits. So yeah, that's um that's the trading system. Um, so yeah, I'm just gonna exit that. You know what? I think I'll just end this here. It was good talking to you guys. I'm probably gonna do another stream tomorrow, so stay tuned and peace out.